All right, let's talk about the invisible side of artificial intelligence. It's something that's happening in the background every single time we ask a chatbot a question, or get it to summarize a document, or even generate an image. We're going to pull back the curtain on the hidden environmental price tag of every single one of those interactions.
You know the feeling, right? You type a question into that little window, and almost instantly, this incredibly detailed answer just appears. It feels like magic. It feels weightless, digital, practically free, but it's not. Behind that screen, there's a very real physical process unfolding. So what is the actual cost of asking an AI just one question? For a long time, whenever you heard about AI's environmental impact, the conversation was always about one thing: training the models. People pictured it as this massive, one-time energy burn, kind of like building a giant library from the ground up. But it turns out, that's not really where the main story is happening. The real story isn't about building the library. It's about what happens every single time someone goes in and checks out a book. That's what we call the inference phase. And this isn't a one-and-done deal. This is happening constantly, all over the world, billions of times a day, every time one of us asks an AI for an answer.
So, just how big is this inference phase? Well, some recent estimates suggest it could be responsible for a pretty staggering 90% of an AI model's entire lifetime energy use. 90%. The training part, that big upfront cost, that's really just the tip of the iceberg. The real ongoing impact is in how we use it every single day.
Okay, so let's get on the same page. When we say LLM inference, we're really just talking about the doing part of AI. It's that moment the model takes what you've typed, your question, your request, and actually generates the answer, or writes that line of code, or spits out that summary you asked for. It's the AI in action. Here's the problem, though. The huge tech companies that run these incredible models, they're super secretive about their energy and water data. They tend to just lump everything into one big number in their corporate reports, which makes it almost impossible to figure out the cost of a single query. So if the data is hidden, how in the world do researchers figure this out?
Well, they basically become environmental detectives. A really groundbreaking new study figured out a way to crack this code. They start with what we do know, public info about a model's performance, and then they apply these 3 key environmental multipliers. First, there's PUE, which tells you all the extra energy the data center uses for stuff like cooling. Then there's WEU, which calculates the total water needed. And finally, CIF looks at the local power grid to figure out the carbon cost. You put all 3 together, and suddenly you've got the full hidden price tag. And once you can see the price tag, you find these massive differences between models. For instance, asking a long, complex question to a super efficient model like GPT 4.1 nano might only use about half a watt-hour of energy. But asking that same question to a more powerful model like GPT 4.5, that single query skyrockets to over 30 watt-hours. It turns out the model you use matters a lot. And that gap can get even crazier. I mean, look at this. The most energy-hungry model they tested, one called DeepSeek R1, came in at over 33 watt-hours. That is more than 70 times the energy of the most efficient model for a single answer. Think about that. Your choice of AI could have a 70x difference in its energy bill. Now, to put that into a context we all know, a regular Google search uses about 0.3 watt-hours. A single, pretty short query to an efficient model like GPT-4o uses 0.42. So yeah, even a quick chat with an AI can be about 40% more energy-intensive than a Google search. And that's just for one little question. So, what happens when you scale this up? Well, this is where the numbers start to get absolutely wild. When the researchers projected the usage for just one model, GPT-4o, for the year 2025, they estimated its annual electricity use could top 463,000 megawatt-hours. That is enough electricity to power over 35,000 homes in the US for an entire year. And it's not just about electricity. To keep those data centers from overheating, you need water. A lot of water. The projection for GPT-4o is almost 1.6 billion liters of fresh water a year. And here's the crucial part. A lot of that water is evaporated for cooling, which means it's pretty much permanently removed from the local ecosystem. To put it another way, that's the same amount of water that 1.2 million people would drink in a year, just vanishing into thin air.
And then, of course, there's the carbon footprint. That same model, GPT-4o, could be responsible for over 163,000 tons of CO2 emissions every year. To absorb that much carbon, you'd need to plant a new forest roughly the size of the entire city of Chicago. And let me just say it again, this is all from the projected daily use of just one model.
Okay, so the logical next step is to just make AI more efficient, right? Problem solved? Well, it's not quite that simple. The researchers point to this really fascinating and kind of worrying paradox, which they nail perfectly in this quote. It's a classic economic idea called the Jevons paradox. And what it says is that whenever a technology makes using a resource more efficient and cheaper, we humans often end up using more of it overall, not less, simply because the demand explodes. So when you apply that to AI, making queries faster and cheaper might encourage so much more use that it completely wipes out any of the efficiency gains. It might even make the total environmental problem worse. So if just being more efficient isn't the whole answer, what is? The study suggests we need a new way to measure these models, something called eco-efficiency. It's basically a score that balances how smart a model is against how much it costs the environment. It's not just about being powerful, it's about being sustainably powerful. And when you look at it this way, a model like Anthropic's Claude-3.7 Sonnet really shines, while that super powerful DeepSeek R1, well, it turns out to be incredibly inefficient for the results it gives.
So the paper lays out this four-part plan for a greener AI future. It all starts with us demanding transparency from the providers so we can actually see what's going on. Then we need serious innovation in hardware and cooling and smarter ways to deploy the models. And finally, they suggest that we might actually need some smart regulation, clear environmental standards for AI to set a benchmark for what responsible development looks like.
Which brings us to this final, really big question. As AI gets woven deeper and deeper into the fabric of our lives, who's on the hook for its environmental bill? Is it the companies building the models, the data centers running them, or is it maybe us, the users, who are driving billions and billions of these queries every single day? That's the hidden cost that sooner or later we're all going to have to confront.